A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Hello there, Herman and Corin. So during these days of war here in Israel and rocket sirens going on and off constantly throughout the day, our lives become a little bit mundane. I guess everyone makes their own decisions about how they want to handle a situation like this, especially one that is dragging on for a month as our current war is. But when there is a war at the moment, I feel weird about doing, and I'm just being honest here, doing things like going out to parties with friends. I definitely have my own coping mechanisms. We watch some movies at home, but it feels a bit strange to me when the country is, being attacked every day and people are losing their homes and being killed to go to a bar. The very second this thing is over, I lose any sense of that feeling weird, and I do very much vibe with that Israeli mentality of life must go on. But there's another reason beside feeling uncomfortable with it, which is that I like to sort of be where I know my area, I know where my shelters are, and until that situation is over, I'd much rather be here than be somewhere else. But I'm getting travel lust or just itching for when we hopefully soon get to a more stable reality that we can go on a trip somewhere. And one of the places I've been in Israel that was super cool and really made an impression on me is Mitzpe Ramon in the south of the country. For those who have not been or not heard of it, it is this desert town that to me feels like what I would love much more of Israel to be. Slow pace of life, chill, relaxed, just pleasant, and it's very creative and artsy. It's a really nice town. There's a couple of hotels for those who are not, self-made millionaires. There are more affordable options as well, which I think is great. There is a very fancy hotel there, but you've also got some cheap places or cheaper places, I should say. One of the attractions in the area is the crater called the Mitzpe Ramon. And this is world famous among stargazers. And they do something cool in Mitzpe at nighttime. They have red street lighting. And we did an episode about how different colors affect melatonin and also affect the amount of light that gets refracted back to the atmosphere. They do that because they want to make the planets visible. But anyway, in the crater, you've got some ibexes, but you've also got some of the most spectacular scenery that I've ever seen. We did a buggy tour that my in-laws graciously took us on, and it was absolutely fantastic. You go out in like an off-road vehicle touring this, and it's just spectacular. It's like you could film a Star Wars movie here, or you could probably take a photo saying I'm here on Mars and somebody would believe it. Like, it looks like something from another epoch of history. And I'm very curious about how it came to be, because I can remember in the visitor center them telling us some facts, but sometimes hard to pay attention when you're just so struck by the view. And it is primordial from what I can remember. Like, it's very, very ancient and some amazing geology that's preserved there. So Herman and Corin, let's go back to geography class for a moment and talk about the Mitzpe Ramon crater, why it is one of the most amazing sites in the world, and what one might want to bring if you want to do your own stargazing. You guys know I'm a bit of a gearhead, and often I feel like if I don't have the gear, I don't own a telescope. It's one of the gaps that I'm just not going to bother. But that's a really dumb way to look at the world. If I did want to take advantage of the cool viewing opportunities, what might you want to bring along to get some nice photos and just to see some of the amazing ways in which our world looked before we began filling every centimeter of it with human-generated stuff. Herman and Corn, over to you.
There is a specific kind of silence you only find in the high desert. It is not just the absence of noise. It is a heavy physical presence that feels like it has been sitting there for a few million years, just waiting for you to stop talking so it can take over again. I was thinking about that this morning because today's prompt from Daniel is about Mitzpe Ramon and the massive crater that defines that whole region of the Negev. He is planning a trip there once the current situation stabilizes, and he wants us to dig into the geology and the technical side of desert astrophotography.
It is the perfect time to talk about it, honestly. Even with everything going on in the north and the center of the country right now, Mitzpe Ramon has remained this strange, high-altitude sanctuary. I was looking at the reports from this week, and while things are incredibly tense elsewhere, Mitzpe has become a refuge for nearly 3,000 people fleeing the rocket fire. It has that Mars on Earth aesthetic that makes you feel like you are on another planet entirely, which I think is exactly what people need when the world feels like it is closing in. I am Herman Poppleberry, by the way, and I have been diving deep into the tectonic history of the Negev all night.
I knew the maps were coming out the second I saw the word crater in the prompt. But before you get too deep into the weeds, we should probably clear up the biggest misconception right at the jump. Most people hear crater and they think of a giant rock falling from space or a volcano blowing its top. But that is not what is happening at Mitzpe Ramon, is it?
Not even close. Calling it a crater is actually a bit of a linguistic compromise. In Hebrew, it is a Makhtesh, and it is a very specific geological feature known as an erosion cirque. There are only a handful of these in the entire world, and the Negev has 5 of them. Makhtesh Ramon is the undisputed king of the format. It is 40 kilometers long, up to 10 kilometers wide, and drops 500 meters down from the rim. If you look at a satellite map, it looks like a giant, heart-shaped bite was taken out of the mountain range.
A heart-shaped bite taken by a very patient giant. So, if it was not a meteor and it was not a volcano, how do you hollow out 40 kilometers of solid rock without leaving a mark on the outside? It feels like a magic trick, where the inside of the box disappears, but the lid stays shut.
It is a process of internal collapse and massive scale erosion that took about 200 million years to play out. To understand it, you have to go back to when the Tethys Ocean covered the entire region. This was during the Triassic and Jurassic periods. You had layers of soft sandstone being deposited in a shallow marine environment, and then later, layers of hard limestone and dolomite were laid down on top of that sandstone as the sea deepened. Eventually, the ocean receded, and tectonic forces started pushing the land upward. This was part of the Syrian arc folding process, which created a massive fold in the earth called an anticline, essentially a long, arched mountain.
Okay, so we have a mountain with a hard shell of limestone and a soft, gooey center of sandstone. It is basically a geological Cadbury egg.
That is a surprisingly accurate way to put it. Over time, the top of that arch started to crack from the stress of the uplift. Rainwater and ancient river systems found those cracks and started seeping in. Once the water broke through that hard limestone cap and hit the soft sandstone underneath, it was game over. The water just started eating away at the sandstone from the inside out. It washed the soft rock away through a single exit point, which is now the Ramon Stream. As the inside was hollowed out, the limestone walls eventually collapsed inward, leaving this massive, steep-walled basin. This is why it is technically a cirque and not a crater. It was carved from the bottom up and the inside out.
It is fascinating because it means the crater floor we see today is actually a window into much older layers of the Earth than what you see on the surface outside. It is like the Earth peeled back its own skin to show us what was happening in the Triassic and Jurassic periods. I remember we touched on some of these hidden microgeographies back in episode 1306, but the scale of the Ramon crater is just on another level.
The depth of that window is what makes scientists lose their minds over this place. When you stand on the floor of the Makhtesh, you are walking on rock that is 220 million years old. You can see the Ammonite Wall, which is this massive vertical surface covered in the fossils of prehistoric sea creatures, specifically these coiled cephalopods that lived in the Tethys Ocean. And then you have the volcanic activity that happened after the crater started forming. There are these things called dikes, which are basically vertical veins of basalt where magma pushed its way up through the cracks in the sedimentary rock. It is a multi-layered history book that you can actually hike through.
And then you have the carpentry shop, or Haminsara. I have seen photos of that place. It looks like someone left thousands of perfectly hexagonal wooden beams lying around, but it is all stone. How does geology get that geometric without a ruler and a saw?
That is quartzite. It happened when a pool of liquid magma underneath the surface heated up the sandstone to incredible temperatures. As the sandstone cooled down slowly, it crystallized into these long prism-shaped columns. It is the same basic physics that creates the Giant's Causeway in Ireland, but with sandstone instead of basalt. The result is a hill covered in these heavy, dark gray blocks that look like they were manufactured in a factory. It is one of the most striking visual examples of contact metamorphism you can find anywhere.
It is wild that all of this is tucked away in the middle of the desert. But that isolation is also why Daniel is asking about the sky. Mitzpe Ramon is not just a geological marvel. It is basically the dark sky capital of the Middle East. It was designated as an international dark sky park in 2017, which I assume is a big deal for the photography nerds.
It is a massive deal. The International Dark Sky Association does not just hand those out. To get that status, you have to prove that you have minimal light pollution and a commitment to preserving the natural darkness. Mitzpe Ramon is at 860 meters of elevation. The air is incredibly dry, and there is almost no industrial light for miles in any direction. This creates a level of atmospheric transparency that you just cannot get in the coastal plain or even in Jerusalem. The crater itself acts as a natural light trap. The high walls block out the distant glow from the coastal cities, leaving the floor of the Makhtesh in near total darkness.
So, if I am Daniel and I am packing my bags for this trip, I am not just bringing a point and shoot. If I want to capture the Milky Way over that crater, what is the actual technical baseline for the gear? Because I have tried taking photos of the moon with my phone, and it just looks like a blurry thumbprint.
Astrophotography is one of those hobbies where the physics of light will punish you if you try to cut corners. If you are serious about it, you need a full-frame sensor. People argue about megapixels all the time, but for the night sky, pixel size is actually more important than pixel count. Larger pixels on a full-frame sensor have a better signal-to-noise ratio. When you are shooting at ISO 3200 or 6400 to catch those faint nebulae, you want as little electronic noise as possible. You are essentially trying to maximize the number of photons each pixel can collect during the exposure.
So, bigger buckets to catch the very few photons that are falling into the crater at 3 in the morning. That makes sense. But what about the glass? I assume you want the widest, fastest lens you can find. Or does that create its own set of problems?
It is a balancing act. You generally want a focal length between 14 millimeters and 24 millimeters. That gives you that wide, sweeping view of the galactic core arching over the crater rim. But the fast part is non-negotiable. You need an aperture of at least f2.8, but f1.4 is the gold standard. The problem is that many wide-angle lenses suffer from something called coma at the edges. It makes the stars in the corners look like little seagulls or boomerangs instead of points of light. So, you have to look for lenses specifically corrected for astigmatism and coma, like the Sigma Art series or the high-end Sony G Master Glass.
I love the idea of seagull stars as a technical failure. But even with a great lens, you are still dealing with the fact that the Earth is spinning. If you leave the shutter open long enough to get a bright image, the stars are going to turn into streaks, right?
If you are using a static tripod, you have to follow the rule of 500 or the more modern NPF rule to calculate your maximum exposure time before star trailing becomes visible. The rule of 500 is simple. You divide 500 by your focal length to get the number of seconds. So, a 20mm lens gives you 25 seconds. But with modern high-resolution sensors, that rule is too generous and you will still see trailing. The NPF rule is much more complex. It factors in the aperture and the pixel pitch of your sensor. Usually, that limits you to about 10 or 15 seconds.
That is not a lot of time to gather light, even with a fast lens. So how do the pros get those deep, colorful shots where the Milky Way looks like a glowing cloud?
That is where the star tracker comes in, something like the Skywatcher Star Adventurer or the Ioptron Skyguider. It is a motorized mount that sits on your tripod and rotates your camera at the exact same speed as the Earth's rotation, but in the opposite direction. You have to align it with Polaris, the North Star, which can be tricky in the dark. But once it is aligned, it effectively cancels out the spin, allowing you to take 2-minute or even 5-minute exposures without any trailing. This lets you drop your ISO down to 800 or 1600, which significantly reduces noise and increases the dynamic range of the colors in the stars.
That sounds like a lot of weight to carry into the desert. Is it actually portable, or are we talking about a whole caravan of gear just to get one shot?
The modern ones are surprisingly compact. You can fit a Star Adventurer in a standard backpack, but you have to be careful with the environment. March in the Negev is beautiful, but it is harsh on electronics. The wind speeds in the crater can be unpredictable. You have these katabatic winds where cold air sinks down the crater walls at night, creating sudden gusts. Even a tiny vibration will ruin a long exposure shot. You need a very sturdy, weighted tripod. I usually recommend hanging your camera bag from the center column of the tripod to lower the center of gravity and dampen any vibrations from the wind.
And then there is the dust. I imagine fine desert sand and high-end optical senses are not exactly best friends.
It is a nightmare. The dust in the Negev is incredibly fine, almost like talcum powder. You have to be incredibly disciplined about lens changes. If you have to change a lens, you do it inside a sealed bag or inside your vehicle with the windows up. Once that fine dust gets onto your sensor, it is very hard to get off without professional cleaning, and it will show up as dark spots in every single one of your photos. And we cannot forget the temperature. In late March, the nights in Mitzpe Ramon can drop to 9 or 10 degrees Celsius, and the wind chill makes it feel much colder. That is cold enough to cause two major issues: battery drain and lens fogging.
Wait, fogging? In the desert? I thought the whole point of the Negev was that it is bone dry.
It is dry, but as the temperature drops toward the dew point at night, moisture can still condense on the cold surface of your glass. There is nothing more frustrating than setting up a 3-hour sequence of shots, only to realize later that the last 2 hours are just a blurry mess because your lens fogged up. This is why serious astrophotographers use dew heaters. They are basically little electric blankets that wrap around the lens and keep the glass just a few degrees above the ambient temperature. It prevents the condensation from forming without creating heat waves that would distort the image.
I am picturing a camera tucked into bed with its own electric blanket and a power bank. It is actually kind of adorable. But speaking of power banks, how much juice are we talking about? Because if you are running a motorized mount, a dew heater, and a camera body in the cold, a standard phone charger is not going to cut it.
You need a high-capacity lithium iron phosphate battery, something in the 20,000 to 30,000 milliamp hour range. Lithium batteries lose their efficiency in the cold, so you always want more capacity than you think you need. And speaking of things you need, let's talk about red light. This is the one thing that separates the pros from the tourists in a dark sky park.
Right, because once your eyes adjust to the dark, one flash from a white flashlight, and you are effectively blind for the next 20 minutes.
It actually takes the human eye about 30 minutes to fully achieve dark adaptation. That is when your pupils are fully dilated and your retina is producing maximum rhodopsin, the biological pigment that allows for low light vision. If you use a standard white flashlight to check your camera settings, you instantly reset that clock. You have to use a red light headlamp. Red light has a longer wavelength and doesn't trigger the same bleaching effect on your night vision. If you show up at the Wise Observatory or a popular stargazing spot in the crater with a bright white light, you are going to make a lot of enemies very quickly.
The Wise Observatory is that Tel Aviv University facility, right? I remember seeing it on the maps. It is about 5 kilometers west of the town. Is that open to the public, or is it strictly for the people with the PhDs?
It is primarily a research station, the only professional astronomical observatory in Israel. They have a 40-inch telescope there that does actual science, tracking near-Earth objects and studying distant galaxies. While the main telescopes aren't usually open for public peeking, the area around it is one of the best spots for photography because it is even further away from the town's light bubble. It is situated on the very edge of the rim, giving you an unobstructed view of both the horizon and the crater floor.
It is interesting that even a small town like Mitzpe Ramon, with only 6,000 people, creates enough light to be a problem. I know there has been some local friction about that lately. The town wants to grow, especially as it becomes this refuge for people from the north, but the naturalists want to keep the lights off to protect the dark sky status.
It is a classic tension. The Israel Nature and Parks Authority is very strict about it. They have been working with the local council, led by Elia Winter, to implement astro-friendly street lighting. These are lights that are shielded to point only downward and use a warmer color temperature, usually around 3000 Kelvin or lower, to minimize scattering in the atmosphere. Even the nearby military bases are being brought into the conversation. The IDF has a huge presence in the Negev, and their security lighting can be seen for miles. Balancing national security with the preservation of a window to the stars is a uniquely Israeli challenge.
It really is, and it makes you realize how fragile these places are. We take it for granted that the sky is dark, but for most people living in the 21st century, the Milky Way is something they only see in pictures. Mitzpe Ramon is one of the few places where you can look up and actually feel the scale of the galaxy.
It is a profound experience, and if you are not a photographer, you don't even need the fancy gear. A simple pair of 7x50 or 10x50 binoculars will show you things that will blow your mind. In March and April, you can still see the winter circle constellations. You can see the Orion Nebula, the Pleiades star cluster, and even the Andromeda galaxy if you know where to look. Binoculars are actually better for beginners than telescopes because they give you a wider field of view, and you can use both eyes, which makes it much more intuitive to navigate the sky.
I think that is a great point. Sometimes the technical gear can become a barrier to actually enjoying the moment. You spend all night fiddling with your star tracker and your dew heater, and you forget to just look up. But for someone like Daniel, who is technically literate and loves the automation side of things, setting up a sequence and then sitting back to watch the sky is probably the whole point.
There is a real satisfaction in the workflow. You capture the raw data in the desert, and then you bring it home and start the post-processing. That is where the real magic happens. You use software like Deep Sky Stacker or Sequator to take 20 or 30 individual shots and stack them. This is a mathematical process that averages out the random electronic noise while keeping the signal from the stars. It further reduces the noise and brings out the faint colors of the nebulae that the human eye can't quite pick up. It is a mix of high-end fieldwork and digital craftsmanship.
So, if we are summarizing the Daniel's trip checklist, it is full-frame sensor, fast wide-angle lens, a motorized tracker if he wants to go deep, a heavy tripod, red lights only, and enough battery power to jumpstart a truck. And maybe a very warm jacket, because the desert doesn't care that it is spring once the sun goes down.
And a lot of patience. You have to wait for the moon to be in the right phase. You want a new moon, or at least a very thin crescent. If the moon is full, it doesn't matter how dark the park is, the moon itself will wash out the stars. I checked the calendar for Daniel, and if he goes in late April or May once things hopefully settle down, he will have some prime dark windows to work with.
It is a good reminder that even when things are chaotic on the ground, the geology and the stars are operating on a completely different timeline. The Makhtesh has been there for millions of years, and the stars have been there even longer. There is something grounding about that.
It puts things in perspective. Whether it is the Triassic rock layers under your boots, or the light from a star that left its source 1,000 years ago, you are surrounded by deep time. Mitzpe Ramon is one of the few places where those two things meet so perfectly. You are standing in a hole in the earth looking at a hole in the universe.
That is a very Herman Boppleberry way to end a segment. A hole in the earth looking at a hole in the universe. I like it. We should probably wrap this up with some practical takeaways for anyone else thinking about making the trek down south.
The first thing is to check the Bortle scale. The Bortle scale measures the night sky's brightness from 1, which is an absolute wilderness, to 9, which is the center of a city. Mitzpe Ramon is generally a Bortle class 2 or 3, which is incredibly dark. If you are coming from a city, it will be the darkest sky you have ever seen. Second, download an app like Starwalk 2 or Sky Safari before you go. There is no cell service in parts of the crater floor, so you want an app that works offline with your phone's internal GPS. It will help you identify what you are looking at in real time.
And don't forget the physical logistics. The crater is a nature reserve. You cannot just camp anywhere. You have to stay in designated campsites like the Bureau campground. The Israel Nature and Parks Authority is very serious about this to protect the local wildlife, like the Nubian ibex. You will see them all over the town, by the way. They have basically become the unofficial mascots of Mitzpe Ramon.
They are surprisingly bold. They will walk right up to your car, but whatever you do, don't feed them. It ruins their ability to survive in the wild and leads to all sorts of health issues. Just enjoy the fact that you are sharing the rim of a massive erosion cirque with a prehistoric-looking goat while looking at the center of the galaxy.
It is a wild world. We should probably mention that if you want to see the maps and some of the technical specs we talked about, you can find more in our archive. We've been doing this for over 1,500 episodes, so there is a lot of ground covered. Check out episode 569 if you want to hear more about how high-res satellite imagery changed the way we map remote areas like the Negev.
And thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
Also, a big thanks to Modal for providing the GPU credits that power the generation of this show. We literally couldn't do this without them. This has been my weird prompts. If you are enjoying these deep dives, do us a favor and leave a review on Spotify or Apple Podcasts. It actually makes a huge difference in helping other people find the show.
You can also find us at myweirdprompts.com for the full archive and all the ways to subscribe.
Stay curious, stay safe, and we will talk to you in the next one.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.